Let us denote for a sequence of values xn the limit superior as x star. Now what is this limit superior? Limit superior is defined to be infimum of supremum of the set of xn for which n is greater or equal to m. We may alternatively think of a set V which contains all those elements which are less than xn for at most finite m. At most finite m, finite number of elements. V is less than xn for finite number of elements of xn of this sequence. And infimum of this V is actually limit superior. Let us discuss this. We have denoted by x upper star as limit superior, and limit superior is nothing but infimum of this limit superior is nothing but infimum of supremum of the set xn such that n is greater or equal to m. So since we know that infimum is greatest lower bound, infimum is nothing but greatest lower bound. So whenever this x star is increased with a arbitrary small amount epsilon, epsilon is arbitrary small positive integer. So x star plus epsilon is not a lower bound since x star is the greatest lower bound. So obviously we have xn which is greater than x star plus epsilon for infinite number of elements, isn't it so? This is the greatest lower bound. This is the greatest lower bound. So if we increase it by a slightest positive amount, this is no longer a lower bound of this sequence, and we must have xn. This is not a lower bound, so xn will be less than this. And if we, this is for finite n, and if we decrease this, so this remains a lower bound because x star is the greatest lower bound. So x star minus epsilon, when epsilon is positive, is always a lower bound, and for infinite m, isn't it so? So thus we define limit superior as infimum of this set, infimum or supremum of the xn's where n is greater or equal to n. They are equivalent. And similarly, we can define the limit inferior as, we can define limit inferior as this, which is the supremum of the infimum of the set. We have supremum of the infimum of the set un, sorry, xn, for which n is greater or equal to m, vice versa.